Okay, let's go through the expectation worksheet. So part 1. The bag contains black and white chips. Rose pays $10 to play a game where she draws a chip from the bag. The following table gives a probability of choosing each color chip. Color is spelled a nice British spelling, is IB. So here we go. Outcome, black, white, probability 4 and 6. Rose gets no money if she draws a white chip. So that means the value here, like we put our X here, our value for white is 0. And she gets K if she draws a black chip. So my value for K is in black is going to be K. The game is fair. So that's vocab, right? Game is fair means that your expected value is equal to the cost. That's all game fair means. If I expect to win $2, a fair game would be I have to pay $2 to play it. So that's all that means. Find the value of K. So again, all we have to do is it's a fair game. So let's talk about this. We play $10 to play. So my expected value should equal the cost, which is $10. Now how do we find expected value? Formula from your formula sheet, which is N times P, which all means here is all you do is you multiply the value of each chip times its probability, and then you add them up to these guys. That's all it is. So it's a sum of N times P. So we're going to multiply K times its value, 0.4, plus 0, white, the odds of getting white, which is 0, or the value of getting white, 0, times its probability, 0.6. Set that equal to 10. This gives me 0. I get 0.4K equals 10 divided by 0.4. And I get K equals, so let's move that over. So I get 100 divided by 4, which is 25. So we should win $25 to make this game fair. Again, all that means is that for this to be a fair game, if Rose plays $10 to play the game, she's only going to win 40% of the time, and she's going to lose 60% of the time. So to make this game fair, to expect the value, her expected win to be what she paid, you have to make the value of winning $25. That's all it means. The next one. Discrete random variable X has the following probability distribution. So 0 is 3/10, odds of getting 1 is 4/10, odds of getting 2 is 2/10, odds of getting 3 is P. Find the value of P. So remember this from before? All your probabilities should always equal to 1. So if I want to find P, I'm just going to go 3/10 plus 4/10 plus 2/10 plus P equals 1. Right? So again, right, when anytime you sum the probabilities, it should equal 1. So if I add these up, I get 3 plus 4 plus 2 is 9 over 10 plus P equals 1 over 10. Sorry, equals 1. That's what it does. Then we're going to subtract 9/10 from both sides. Common denominator. I'm going to get P, subtract this is like 10 over 10. P equals 1 over 10. So that's my probability. Now they want me to find the expected value. Well, so now I know what P is. P is 1 over 10. Remember, all you do for expected value is just the sum of N times P, or some people say X times P. X. Right? All you have to do is multiply the X times the probability and add them all up. That's how you find expected value. So we're going to go 0 times 3/10 plus 1 times 4/10 plus 2 times 2/10 plus 3 times 1/10. Now keep in mind these are all over 1. So if I add those all up, I'm going to get what? 4/10 plus 4/10 plus 3/10. So I get a total of 11 over 10, or 1.1. So my expected value for this probability distribution is 1.1. So a goalkeeper has a probability of 3/10 of saving a penalty attempt. How many goals would he expect to save from 90 attempts? So now remember, expected value is the exact same thing as just the average. Right? The average of something is what you expect to happen. So that's the exact same thing the expected value is. These are exactly the same thing. So if I want to find the expected value here, you can look at the average formula, which is just N times P. What's my N? Well, the number of times it happens, 90. What's my P? The probability of it happening, 3/10. So if I do that, well, cross multiplication, I'm going to get 27. So if on average he saves 3 out of 10, or his probability of saving is 3 out of 10, what's the expected value, the expected saves of 90 attempts? Just multiply them. 3 tenths times 9 times 90, you get 27. Next one. A charity fundraiser gets a license to run the following gambling game. A die is rolled and the return to the player are given in the play table. So this is what you win. If you get a 6, you get a 10. If you roll a 4 or 5, you get a 4. If you roll 1, 2, or 3, you get a 1. To play the game costs $4. Very important, right? The cost to play the game lets me know if it's a fair game or not. And then the rest are just the same thing I said earlier. So again, all we're doing here is rolling a die. And remember, when you roll a die, your odds are 1. You get 1, 2, 3, 4, 5, or 6. So you have 6 options. So what are your chances of playing one game and winning $10? Well, the only way you get $10 is if you roll a 6. That only happens 1 out of every 6 times. So 1 out of 6 would be my probability. Of getting a 4, well, there's 2 ways to get a 4. Of getting a 4 or 5, so it'll be 2 out of 6. Getting a 1, well, there's 3 ways to get a 1, so 3 out of 6. Okay, the next one, your expected return for throwing a 6 is 1/6 times 10, because that's the odds of getting a 6 times the value of getting a 6. What's your expected return from throwing a 4 or 5? Well, same idea. So what's the odds again of throwing a 4 or 5? Like we talked about right here, 2 out of 6. And the value of getting thrown a 4 or 5 is $4. So I'm going to get 8 over 6. A 1, 2, or 3. Well, what's the odds again throwing 1, 2, 3? 3 out of 6. Right? There's 3 things and there's 6 options. And what's the value you get? $1. So 3 out of 6. What's the expected return when you throw all this? So this is basically what's the expected value, right? When you throw everything, what do you expect to get? A lot of times I like to make my little table here. So here's my X, here's my P. So you could either get $1, and that's odds of getting that, or 3 out of 6. You could get $4, and that's 2 out of 6. Or you get $10, 1 out of 6. If you want the expected value, just multiply these together and add them up, which we kind of already did. Right? We're going to multiply 1 times 1/6 plus, 1 times 3, 6, plus 4 times 2, 6, plus 6 times 10 times 1, 6, sorry. You get $10 for getting a 6. And then simplify it. I get 3 over 6 plus 8 over 6 plus 10 over 6. Add these all up, and I get 21 over 6. So about $3 and, let's see, $3.50? 3.5. So the expected value getting is about 3.5. What's your overall expected result at the end of one game? Well, it cost me $4 to play, and I'm only getting on average, I'm getting $3 back. So $3 was what I expect to get, and I pay $4. So every game I'm getting an average of minus 50 cents or minus $0.5. Not the best, not great, Bob. Oops. So next one, what's your overall expected result at the end of 100 games? So what if you, okay, like let's 100 times down. Let's play some more. Well, on average, you go 100, you just multiply that by 100. So I'm gonna lose about $50. Right, so that's the idea. If the expected value is about 0.5, that's the expected value, that's the average value, and you're gonna play that game 100 times, you just multiply by 100. Now again, that's the expected value. You might get lucky and get all $10, but on average, that's what expects to happen. That would not be a fair game, as you can see. Fair game should be net neutral. Even if it's like advantage, even if it's like, oh, plus $50, not considered fair. Fair is neutral. Next one. Person rolls a normal 6-sided die with the win number of euros shown on the face. And wins the number of euros shown on the face, sorry. I could read sometimes. So all I mean here is if you're throwing a 6-sided die like 1, 2, 3, 4, 5, 6. If you get a 1, you get $1 or euro. Sorry. If you roll a 2, you get 2 euros. You roll a 3, you get 3 euros, and so on. Find expected return of one roll of the die. So anytime I see this, I draw my probability distribution like we did earlier. So I do this. I go my X. I go my P. I could get a 1. I could get a 2, a 3, a 4, a 5, or a 6. Right? That's the things I could roll. And then you get the exact same. Now And then since I get the same value as the face, this is my value, right? If I roll a 1, I get a 1. If I roll a 3, I get a 3. The probability, well, what's out to getting a 1? There's only 1 out of 6. So 1 out of 6, 1 out of 6. They're all going to be the same. Like that. And then to find the expected return, right? That's expected value. That's the sum of x times p of x, or just n times p. All we're going to do is multiply these together and add them all up. So 1 times 1, 6, plus 2 times 1, 6, plus 3 times 1, 6, plus 4 times 1, 6, 5 times 1, 6, plus 6 times 1, 6. If I do all that, I'm going to get 1 plus 2 is 3, plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, so 21 over 6. Okay, so again, we got another about $3.5. Or euros, sorry. You get about 3.5 euros each time. Find the expected gain if it costs $4 to play the game. Would you advise person to play several games? Just like before, I want to gain $3.50. It cost me $4 to play, so no. The game would be a loss of 50, half a euro. So no, I would not advise. Suppose it costs K to play the game. What value of K would result in a fair game? Well, like we just talked about, fair game is where the expected value equals the cost. So a fair game would be a game that costs $3.50 to play. There you go. Sorry. 350 euros to play is what I meant to say. And what value of K will result in a profit being made by the vendor? So now, again, the vendor's person actually like setting up the game up, not the player. So, well, 350 is like the break-even point. Anything that costs more than 350 is a profit made by the vendor. Anything that, if you charge less than 350 to play, then it's going to be profit for the player. So for this anything that's bigger than 350 euros. Anything above that, the vendor makes money. The house always wins. So there's that one. Move on to the next one. A random variable x has a probability distribution given by this for x equals 1, 2, 3. Calculate the mean of this distribution. Remember, mean is another fancy way of saying expected value. That's all it is. It's another way of saying that. Mean expected value are the exact same thing. The mean, the average expected value, all the exact same thing. So with this, I'd like to make a probability table. So I'd like to go. So we're going to have probability and other way around. X is on top, probability is on the bottom. We have 1, 2, and 3. Now remember the way we find 1, we're just going to plug it into this thing. So probability at 1, you have a formula for it, you plug it in. We get 1 plus 1 over 2, or 2 over 20. I'm not going to reduce it because I think it's going to be a little easier at the end if I don't reduce it. Next, we plug in 2. So probability at 2, just plug into the formula. 2 squared is 4. 4 plus 2 is 6. Now, there's two ways I can do this last one here. If you look what we have a total of 8 over 20. Well, with this, all the probability has to equal up to 1, right? So what's missing? 12 out of 20. So that's one way you could do it, right? See, I know all this has to equal 1. I know right now I have 8 out of 20. So what's left over? 12 out of 20. Or you just plug in 3. So 3 squared is 9. 9 plus 3 is 12. 12 over 20. Right, so don't forget though, this always has to equal 1. So if you have 2 of them, you're golden. It's got subtracted from 1. So that's my probability distribution. And they want me to find the expected value. So remember the way we find the expected value? It never changes. It's just the sum of x times p of x. Or some people like to say n times p. So we're just going to multiply these together and add them up. That's all we're doing. So multiply 1 times 220, 2 times 6 over 20, 3 times 12 over 20. So this times this, plus this times this, plus this times this. So I get 2 over 20 plus 12 over 20 plus, remember these are all over 1, so you just multiply the tops. 36 over 20. And all together I get, what was that, 48, 50 over 20. Or 5 over 2, or 2.5. And that's the average or mean or expected value of this probability distribution. Next one. The country exports crayfish to overseas markets. The buyers are prepared to pay high prices when the crayfish are still alive. Wow, that's morbid. If X is the number of deaths per dozen crayfish, the probability of distribution of X is given by this. Okay, so again, X is the number of deaths per, so 0 deaths in a dozen, 1 death in a dozen, 2, 4, 5. So this is the average of it. So at least on average, no one dies. So first, let's find K. So like as we always talk about, if you add up all the probabilities, it should equal 1. So for A, if I go 0.54 plus 0.26 plus 0.15 plus K plus 0.01 plus 0.01 plus 0, that should all equal 1. And then I subtract that from 1, and I get K plus 0.97 equals 1. So minus 0.97 minus 0.97, so 0.00. And I get K equals 0.03. So that's the odds of having 3 dead crayfish in a dozen. Over a long period of time, what is the mean number of deaths per dozen? I'm sorry. Mean number of deaths, again, it's its expected value. It's a fancy way of saying that. So all we're going to do is multiply each of these together and add them all up. Now again, even this, like, how do I multiply that? It's a 0, so it goes away. So we're really just multiplying these guys. So it's going to be 0 times 0.54 plus 1 times 0.26 plus, this is for B, plus, where am I at? 2 times 0.15 plus 3 times 0.03 plus 4 times 0.01 plus 5 times 0.01. I'm going to plug that all into the calculator. I'm going to get 0.74. So they average about less than 1 death per crayfish. That's what that means, per dozen crayfish. So that's what the expected value means, right? So if I would have got like a 2 there, I'd expect to get a 2 deaths for every dozen. But in this case, less than 1 death per every dozen. Okay, next one. The random variable X has the probability distribution function P of X described in the table. So right here, find K. So, done this a lot, right? Let's add them all up. 0.10 plus 0.3 plus 0.45 plus 0.10 plus K equals 1. So I get what? 0.4, 0.85, 0.95 plus K equals 1. Subtract that, K equals 0.05. Find the probability X is greater than 3. So, very important here, it's X is greater than or equal to 3. So I'm using these two. If it just said greater than 3, I'll just be using the 4. But greater than or equal to 3 is these two. So for my B, I'm going to add up the probabilities. 0.10 plus K, which is now 0.05. And I get 0.15. C, find expectation for the distribution. So find expected value. Again, all we're going to do is multiply these together and add them up. Simple. 0 times 0.10 plus 1 times 0.3 plus 2 times 0.45 plus 3 times 0.10 plus 4 times 0.05 equals, and again, I'll just plug this into the calculator, and I get 1.7. So there you go. So simple. We've done that many times. Let's move on. In a game, the numbers from 1 to 20 are written on tickets and placed in a bag. The player draws out a number at random. He or she wins $3 if the number is even, 6 if the number is a square number, and 9 if the number is both an even and a square. Calculate the probability that it wins $3, $6, or $9. So in this case, we just got to figure out what all that stuff means. So numbers 1 through 20. So like there's 1, 2. I'll try them all out here real quick. There we go. 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. Okay, and then what's going on here? So $3 if it's even. Well, there's going to be half of them, so I know it's going to be 10 out of 20. Right, there's 20 numbers, half of them are even, so 10 out of 20. If the number is a square, you get $6. So where are my squares at? So 4 is a square, 9 is a square, 16 is a square, right? And 1's a square. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and then 5 times 5 down the list. So there's 4 of them. So 4 out of 16. 4 out of, what am I saying? 4 out of 20. And then finally, and if 9 is, the number is both even and squared. So there's gonna be some overlap. So I think I did this wrong. So I think it's kind of work backwards actually. So red's already used. 9 if it's both even and squared. So I think that takes paramount out. So even square numbers are 4 and 16. So there's 2 of those out of the 20. Now, if I add all these all up, I'll get 16 out of 20. That doesn't seem right? That's way too much. So I'm gonna take down some. So I'm not gonna double. Right now I'm kind of double counting a lot of things. So I'm gonna take those out. So there's only 2 out of 20 of those, the big rollers, and then let's work backwards. So 6 of the numbers is a square number. So the squares that are not even are 1 and 9. So I think there's actually only 2 of these also. And then finally the even numbers. Now, even numbers are not squares, I believe we're going to talk about. So there's 10 even numbers like we talked about, but 2 of them are squares. So take those out. There's actually only be 8 even. I feel a lot better about this. So 8 out of 20, 2 out of 20, and 2 out of 20 is, I believe, is what they want. And then you got to think about, then you're going to say it. Well, if you don't get one of those things, you get $0. How many are zeros? Well, all the leftovers, all the odd ones. And not 1 and 9, so 8. So you get nothing if you get an odd number that's not a square. There's only 8 of those. Right, so all the odd numbers are not evens, but 1 and 9 are squares, so take those out and you get 8 out of 20. Now look at all this. If I add them all up, 8 plus 2 plus 2 plus 8, that is 20 out of 20. So it makes sense logically. So sorry if that was a little confusing. The question's not worded very well. I think you have to go 9, find both the squares and the evens. So that's 2 out of 20, only 2 squares are even. And then go over here, the squares are not the even ones, so 1 and 9. And then that makes this just the evens that are not the other guys. So that makes 8 of those. And then you make no money if you get anything else. So that's A. Sorry again, that was kind of confusing. Not a very good question. How much should be charged to play the game so that it's a fair game? Well, as we talked about, a fair game is when the expected value equals the cost. So I got to find the expected value. To do that, we make my favorite little table. X and P. And then we have what? Let's say $0, my X. That happens 8 out of 20. We have getting $3, and that happens 8 out of 20 also. We have getting $6, that happens 2 out of 20. And we have getting $9, that happens also 2 out of 20. To find expected value, we're just going to multiply these all together and add them up. So 0 plus 3 times 8 out of 20 plus 6 times 2 out of 20 plus 9 times 2 out of 20. And that goes over 1 if it helps. So I get 24 out of 20 plus 12 out of 20 plus 18 out of 20. If I add these up, I get 30. I get 54 out of 20. So about 2.2-ish. Oops, that was an accident. So 54 out of 20, I'm going to type that in real quick. And I get about $2.70. That's how much we should charge. I'm not sure what that is in euros. But in dollars, $2.70. So I'll make it a fair game. Anything above that, then we'd be making money. Anything below that, whoever's playing the game makes money. Okay, a couple more and then we're done. Like Shimi rolls a number-sided die. She wins twice the number of pounds as the number shown on the face. How much does Shimi expect to win from normal die? So it's kind of the same question, but this time, let's make our favorite little probability distribution table here. She throws one normal die. I could talk sometimes. So we have what? 1, 2, 3, 4, 5, 6. Ugh, it's a bad 6. Now here's the problem. You're actually not winning that time, not my X. We win twice the amount on the face. So I'm actually winning $2 here, $4 here, 6, 8, 10, and 12. Right, you double the face. Odds of getting these guys? Well, they're all the same. You're just rolling dice. So 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. And then with respect to win, that's just the expected value. N times P. So we're going to multiply all these together, all the red ones together, and add them up. So I'm going to get 2 times 1 over 6, plus 4 times 1 over 6, plus 6 times 1 over 6, plus 8 times 1 over 6, plus 10 times 1 over 6, plus 12 times 1 over 6, add these all up, and I get 7 pounds. I don't know the symbol for pounds. Oh, there it is. 7 pounds. If it costs $8 to play the game, would you advise looking to play several games? Explain your answer. No. Right? Our expected value is $7. It costs $8 to play, so it's not a fair game. It's not even like I would advise her if we're making money, but we're actually losing money. So no. On average, you lose about $1 or £1. Sorry, it's a fancy symbol per play. Again, it's on average. She might win. She might win big, but on average, she'll lose. She'll lose more than she wins. She'll lose about $1. All played out. Okay, the last one. If 3 coins are tossed, what is the chance they all fall heads? So we're tossing 3 coins. So my first coin, my second coin, my third coin. Again, that's the first toss, second toss, third toss. Or first coin, second coin, third coin. What's the odds of getting heads? Well, 1 out of 2. What's the odds of getting heads here? Well, 1 out of 2. Odds of getting heads the third time? 1 out of 2. Doesn't change. Multiply them all together, you get 1 out of 8. So if you toss 3 coins, the odds of getting all heads will be about 1 out of 8 times. B, if 3 coins are tossed 200 times, how many occasions would you expect them to all fall heads? Well, this is just an expected value question, right? That's just n times p. What's my n? Well, 200 times we're tossing it. What's the p? The probability of getting all heads, which we just figured out 1/8. Classic IB. So, whatever 200 over 8 is, that's the answer. That's the homework.